Hello and welcome to this mesh node code setup video. What we're going to focus on here is essentially setting up our mesh subclass to our DAG node. So let's go ahead and open up our rigging tools, and we're going to go down into nodal because this is not a base attribute that isn't being used within our initial hierarchy. What we're going to essentially do is add this to the nodal class or the nodal folder structure. So let's go Python file. Probably say that this is our mesh node because you might have mesh functionality within utils or with somewhere else. So we'll call this mesh node. All right, perfect. And now let's go into our DAG node. Let's close a little bit of the extra windows we have open. There's quite a lot going on. We've got dep node, DAG node, mesh node. Okay, and in that order. So let's go up. Now let's copy essentially all this first section. And within our mesh node, just go to the top. Let's start at the beginning. Just change the class name to mesh. Let's delete the doc string that we have here. And now let's also just say our mesh node functionality. Okay, perfect. So we will be needing the Maya commands. We will be needing the dep node. And will we be needing the dep node? I do believe so, actually. We're dealing with everything with dependencies in here. So we will just need a DAG node. Let's change this out to DAG. And then remove these. Great. Okay, there we go. We have everything we need right now. And then we will say DAG. So here we're not actually going to create anything. We're always going to assume we are passing a mesh through. But we are going to check that we are on the mesh node. Okay, we're going to do this by, again, checking our node. And we are going to say object type node equals mesh. And if it does, what we're going to do is we're actually going to set our node to being its parent instead, because we don't really want. Should make that readable. Let's go with parent rather than offset. Okay, so essentially we don't want to work with the shape node. We want to work with the base DAG node that then holds the transformations and the shape which we can get. But okay, I think we have everything we need here. So we're just going to call this mesh. We're going to call this mesh node. We'll call this mesh. It is within mesh node, but we will just call this mesh. And now let's go to the initiate, and we will make this easily callable as well. So we'll put this on the line below. Actually, we'll just go from modules.nodal import. Sorry, I should say mesh node import mesh. Perfect. There we go. Again, abstracts away one level for us, but again, makes it nice and easy for us to call. Okay, perfect. See, one usage already picked it up. Great. Okay, great. Let's start it on with our functionality. Now, as you'll know from a lot of my previous classes, we are. Let me jump to the beginning. Oh, funny old stuff. What I am handing over is a blueprint for pretty much all of these setups. As I've said, these are pretty big on within my system. For example, the mesh node here has been cut down from about 500 lines. And a lot of that functionality is actually then abstracted away. So this class is 500 lines of mostly just calls to utilities essentially that are doing all the work for it, and to deform.skinCluster. Essentially, that is another, again, class that we have, a module and class that I have. But we're going to keep all the functionality in here for us, but we are going to break this down into some sections, which again, you can then expand on in the future as you see fit, because these are the functions that we are going to, or the sections that we are going to cover. But for example, I have another 4 or 5 of these. And I think for some of these, you've got things like deform. I think that, I mean, again, I'll tell you how useful they are, but you can add essentially access to lattices, to deformers, waves, anything that is deforming a mesh. You can add access to that deformer. Put that under another title here, deformer. You could also add access to the blend shapes, the blend shape chain, everything, the way that something works, and then just abstract away the complexity and put it within this class. So it becomes very powerful very quickly. But okay, let's have a little look at formation and put some properties in. We are going to give ourselves a few properties here. Let's go, I'll just go verts for short. And again, you'll probably know the Maya commands for these are pretty straightforward, but let's write it out on all of them and then we'll just append where we need. So return m.list self.full path plus string dot vertex, if we use the top as the primary example. And then we want that as a flattened list. So this argument, keyword argument, stands for flatten. Okay, so now we want edges as well, which is .e. And we want f, essentially for faces. So we're essentially going to search for every face within the mesh that is being passed here. Okay, giving us quite a lot of, again, ease. And as we spoke about in the introduction, for example, this is where you could expand this out. I'm going to leave some of these things for you for homework. You can do vert translations, where your vert translations property essentially uses the verts that are gathered and then creates and gets all of those translations. Very, very nice method to use. I use it quite a lot, especially if you're adding to a vert, if you want to try and make a vert matrix constraint, or if you want to do something interesting. Knowing the vert and a mesh within a class, again, gives you access to all of that other functionality you can start writing. Okay, great. We've got our 3 properties here, our first 3 properties. Perfect. Type, again, let's just go for a nice little property here. Again, overriding a little bit of the functionality we had. And we are going to return object type and self.shape. Okay, perfect. So again, we are going to get the type from shape. If we just use the base DAG node, we will essentially just get transform back. So we want to essentially inquire as to the shape. And here, if there is no shape, let's have a look what happens. If there is no shape, then we'll just be returning none. I see. So we'll just be getting none type back. Okay. So now for the fun stuff. Okay, let's do a few of our properties that we need to work with. First, we need the joints, and we need the skin cluster from our mesh item. I mean, what just happened to, oh, it's indented. Wow, it jumps you around the screen a bit, doesn't it? So a few little things, I think, in the updates that they've had in the last few years where things change a bit and you're like, oh, I don't like that update. It's 2 steps forward, 1 step back. And it didn't used to, a few years ago, actually jump around so much. You used to type stuff in. And then all of this, and it's useful information, but it jumps you up and down, which isn't too good. Okay, so let's type in joints. Sorry, I might start babbling a bit more. It is 1 a.m. on a Friday night. I just want to get this all done. So we've got joints and skin cluster, both properties. So to get joints, we're going to use, again, another bit of our Maya commands. But actually, we probably put skin cluster first. So let's highlight that, Control-Shift, and press up, because we're going to use skin cluster within joints. So we'll do this one first. So skin cluster, we need to say from, actually, no, we do need dep node, don't we? Let's return this because a skin cluster is a dependency node, not a DAG node. Okay, let's add that in at the top. And then we will say, so skin cluster. So here we go. Here's our functionality. What we're doing is we're getting the skin cluster, and now find related skin cluster doesn't have a Python kind of version, weirdly, but it works perfectly. So what we do is we're going to essentially use mel, which we can import mel in very much the same way that we have already imported commands. We can go from Maya, import commands, but what we're going to do next is from Maya, import mel. Okay, perfect. So we've imported mel. We'll jump back down. And you'll see what we're doing is we're actually appending into our mel eval. So this is essentially just giving us a mel, a Python way to run a mel command. And what we're going to do is we're going to go find related skin cluster, and then we're going to put in the full path of our mesh. And we're going to return that skin cluster as a dep node. Because again, we are in a class-based system, so we want to return the correct class type for that item. And this is an item without dependency, and therefore it should be a dep node. All right, great. Let's move on. And now let's get some joints. So you see, because we have a dep node, what we can do is now check for its existence. One of the many cool features that we now, because we're getting used to having everything as a class-based item, what we're doing is being able to access everything in a class-based way, which again is making everything feel very readable. And then return the influences. Okay, perfect. So what we are doing here is we're essentially, we should say dep and dag node. Here we go. We're not namespacing them here. So with our joints, what we're getting here is influences. Okay, we are saying, well, if there is a skin cluster, then we should be able to get the joints that are associated with that skin cluster. So if there's a skin cluster, then we are going to return each one of the joints and make it a DAG item. When you've in the future made your joint subclass, you can make it a joint. But at the moment, what we're going to do is just make it a DAG node. Okay, and we're going to get each one of those joints. So we're going to say M, so my commands, skin cluster, and then look at this skin cluster and please query and get me all of the influences within that skin cluster, and then cycle through them in this list comprehension and make them into a DAG node and return those influences. Again, nice, powerful little way of working. Okay, cool. Now let's do our nice little function. Let's start with weight too, because again, nice, powerful little way of working. So weight 2, a nice simple essentially setup that we are again hijacking the my commands, giving ourselves a nice way. I mean, you do have m.bind, but I like weight 2, and we're going to keep it consistent with the way that we copy weights. So you'll see my madness in a minute. But we're going to go with weight 2. We're going to be passing it the joints, and then you're going to give the keyworks. So you can query, you could influence, you can do kind of any one of these, a number of things. Oh, well, not so much query, because obviously we'd be expecting something back there. But what we are going to do is use this to do all of our weighting that we need to do. And now let's use another couple of commands, which will give us a really good series of defaults. Now def soft weight 2. Then we have hard weight 2. Yeah, really good again for some items. You might know the exact fall off. Again, you can use your dimensions node .o.width to see the dimension, to see the width dimension. And then if you've got 5 joints across that, you could set the weighting fall off to be divided by those 5, and then set the parameters based on that. So you see our object dimensions and will help us essentially do weighting as well. But hard weighting is essentially just going to hard weight to all the objects around it so that you can hard weight and then just blend in the weighting yourself. But let's write that functionality in. So we've got soft weight 2, which is going to take some joints, and then it's got a series of default parameters, but we can also pass it keywargs as well. So we can overrule these and also pass keywargs. And then what we're going to do is then use the weight 2 functionality, pass it to joints, and then go through and weight to that item with the soft weighting parameters. Hard weight 2 is going to be a little bit different because we're expecting this to be hard weighted. We are literally just going to go for closest joint and make sure that each joint has 100% weight over every vertex that it chooses near it. So we're not going to soft weight in, we're not going to smooth in. But again, I'd suggest you go through, have a look at Skin Cluster when you do need to use this functionality, because then you'll be able to cycle through and see, okay, well, this is the drop off, this is the influences, the maximum number of influences per vert, and you'll be able to kind of read through all of these different sections. But okay, there are our first 3 functions that give a nice little bit of useful kind of ability to us within Skin Cluster, or within the Skin Cluster section. But now let's add one of the best ones, which again, kind of your bread and butter, especially when updating mesh and doing kind of tasks that could otherwise take quite a lot of time. And that is going to be def copy weights 2. Okay, perfect. So weight 2. We're using here, again, we're checking that we have a skin cluster because that's what we're going to be copying from. So there's no point in even accessing this if we don't have a skin cluster. And what we're then going to do is cycle through all the meshes, make sure that they are mesh items. And then for each mesh item, we are essentially then going to get all of the joints, the joints that we have on our mesh. And then if the item has a skin cluster, we'll just go ahead and delete it. So if skin cluster, just delete it. And then what we're going to do is just hard weight the joints that we have on our mesh to that item. And then copy skin weights. We're going to use the closest point, and then we're going to use one-to-one weighting, essentially with the source skin cluster, which is self, and the item skin cluster, the newly made skin cluster there. So essentially we are, again, making everything very easy to work with because we now have 2 mesh class instances. We have self and we have the item that we're working to, and we're using all of that functionality just to copy our weighting over based on a few simple parameters. But now we can also flip that and reverse it. I'm not Missy Elliott, I promise. Copy weight from. And we are going to just say item here because we shouldn't have multiple items we're copying weights from. We should just be using one. And what we're going to say is mesh item, which again, we are going to assume that, I mean, if we are past the mesh item, it won't matter because essentially this will be turned into a string, but then passed straight into mesh and will be reinitiated as a mesh, so it won't really matter. But then we're going to go mesh item dot copy weights to, and then self. So we're just flipping the argument around essentially. So copy weights to, which is our item copying to items, our mesh object copying to items that have been passed. And then we have also got copy weights from, which will essentially copy the weights to our item. Okay, now for topology, as I was saying earlier, again, and then within weighting, again, you can do a lot of more fun things. So I should kind of finish it. These are our classes we're going to, these are our functions we're going to use for the minute. But you can also add quite a lot more functionality to here. You can add auto weighting. You could add projector creation. You can add a lot more smart methodologies getting the position of verts relative to the joints, therefore giving you a nice weighting, kind of auto weighting system. Just a little bit of a clue there for you to what you can work on and play with in the future now that you're an awesome Python developer. Again, feel free to send these things to me. I'll try and give what information I can to you to say how you can make it better, or what you could do that would maybe improve it, or if you've got anywhere where maybe you can optimize your script to cut down on recursion, or essentially functions that are using a bit too much memory maybe. So let's have a look at topology though. And in this one, we're going to keep it very simple. I'm just going to go delete tweaks. So again, really simple example of just another little useful bit of functionality. So with delete tweaks, we already have delete, so we can already delete this mesh item because we're inheriting that all the way through from our dep node. But what we can do here as well is also just delete tweaks. So if there's any, if you've accidentally done a huge amount of work in the tweaks, or if there's a little bit of mess on your item, you can just delete tweaks. And again, another little bit of a heads up. So with this section, what you could add is also a clean mesh. So you could remove unneeded influences. You could make sure that the item is in its resting position when all deformers are turned off, so that you have so that you're checking it for when you're making blend shapes. You can do lots of great little things in here. You could check if the items are symmetrical. Again, these items essentially I have in my class setup. You can check the left vert to the right vert. You could do lots of very cool things and store it all in a dictionary. And Python works very quickly when written well. Or you can check if something is symmetrical, which I can do to within 10,000th of a unit very quickly in Maya. And then you can check lots of other things. Essentially, you can check from left vert to right vert, make sure you get a dictionary in place to do that, which again allows you just to be able to move items around in the scene, copy controllers left to right very easily, because you have a series of commands within different node types to do all this for us. But at the minute, we're just going to delete node tweaks in here. And now our last function we are going to write is duplicate. Okay, last bit of functionality. So we are just saying here, well, let's duplicate. Let's go through this. And you can maybe, again, add some extra functionality for these. So, duplicate as is, duplicate special. You could add your own kind of abstraction of Maya's complexity, but put it in here yourself. So have different versions of duplicate. But for this one, we're just going to duplicate what we have. Using Maya's duplicate or Maya commands duplicate. But we're going to say, well, if there's not a mesh that exists and you're trying to duplicate, actually warn the user and say no item to duplicate. Okay, now, so what we will return is the mesh object of the item that's duplicated, the full path, and the keywargs. Now, assuming in this keywargs that you will probably have name equals or n equals, because you will need to rename it. If not, it will just do your mesh name, say sphere underscore geo 1, sphere underscore geo 2. It will just do exactly what happens in Maya, so we'll keep consistency with that logic. Okay, awesome. Let's have a look up here. We've got 1 warning and 2 typos. Ooh, where are typos? Oh, verts, skin cluster. Where's this? Oh, this is okay, just the title. Okay, fair enough. Well, yeah, again, like it, very useful, but not so much for us right at this moment, because we want to keep these uppercase just mainly for the ease of reading. But brilliant, there we go. We now have our mesh node functionality, and you can essentially start streamlining your mesh workflow. Ooh, other topology checks, yeah. So essentially, okay, I should say what I'm using them for. So checking symmetry, checking meshes for materials that are on them, checking meshes that have a history on them. Again, you can use the history that we are using in the hierarchy from our DAG node. Again, these are all things that you can then run into your library, which you can then run scripts on modeling scenes that are passed to you, and you can very quickly check, oh, actually this isn't symmetrical, or these aren't, all these meshes aren't zeroed out, they all have values. You can start writing very quick checks for people's meshes they're sending to you to see if they're good, okay, or if they work, or if they have issues, because you may have like a whole bunch of topology that isn't symmetrical, but that's fine. Asymmetrical geometry is just something you have to work with, but it's good to always be able to actually check on that before you start working on it, and you've done a huge amount of work. Well, then and then the modeler's off the job, and you don't have a modeler to even fix the work for you. Okay, let's end it there. Thank you so much for watching. In the next lecture, we're going to go on and we are going to write some tests for our setup.